Okay, third page of the 3.1 notes. Now here, referring to the three graphs that we just dealt with at the end of the first video, how could you eliminate the zeros, the x-intercepts, on graph number 2? So if we go back to those previous three graphs, if we look at graph number 2, how can we eliminate the x-intercepts? Well, if I take this whole graph and shift it up a bit, that would probably work. And then how far do we have to shift it? Now, you probably have to look closely at your page, but it says that this little tick mark right here is -2. This is -4. -3 is going to be about there. So if we shift this thing up 3 units, or let's play it safe and say up 4 units, well, then that would get rid of all of my x-intercepts because all my lowest points would be above the x-axis. So then to answer this question here, how could you eliminate the x-intercepts on graph number 2? Shift up, and then we can say maybe at least 3 units. Okay, because if we shifted up 3 or more units, then that would get rid of the x-intercepts. Okay, how about graph number 3? Could you eliminate the zeros on graph number 3? Okay, so if we look at graph number 3, okay, well then, yeah, this is the highest point on my graph, so if I shift it low enough, then yeah, I would get rid of my x-intercepts. Let's see, this is up 2, 4, so it looks like 6 would be plenty there. So if I shift down at least 6, that would work for this graph. So let's say for part B, we'll shift down at least 6 units. All right, and then part C, well, how about graph number 1? Where do we have to shift that thing to get rid of its x-intercepts? All right, let's see. Well, this thing goes down forever, this thing goes up forever, so no matter how far up I move it, this is always going to hit the x-axis somewhere. No matter how far down I move it, this side is always going to hit the x-axis somewhere. So can we get rid of the x-intercepts here? No, we can't do it. We can maybe change the number of x-intercepts by moving this just a little bit, but no, we can't get rid of them. So we can say no shift will eliminate x-intercepts. No shift will eliminate all x-intercepts. So we can eliminate a couple of them, but not all of them. Okay, and that works for that. All right, next, write a polynomial function, and polynomial is just basically the name of one of those big equations. Okay, but write a polynomial function with n behavior on the left for my y values that goes to -infinity. So in other words, it goes from low to, and then my y values on the right goes to +infinity. So low to high. So that's basically what we want, is an equation that goes from low to high. Okay, now what do we have to have in order for our equation to go from low to high? Okay, well, first of all, we need to have a function, so we can put f of x equals, or you can put y equals if you want to, doesn't matter. And then in order to go from low to high, so that's like a line with a positive slope, which would look something like that. Okay, well then it's got to have a positive leading coefficient, so we can say like 3 times x raised to what power? Low to high, it's got to be some odd power, so pick an odd number. How about 7? If you just put 3x to the first, that's fine, you're done. So I can have 3x to the 7th. Do I have to have stuff after it? No. Can I have stuff after it? Sure, I can put plus 4x to the 4th. Okay, and then I can stop there. Or I can put, minus 2x to the 3rd. I can stop there, or plus x. And I can stop there, or minus 3. All this stuff doesn't really matter. It can be there, it can be different, it cannot be there. What we have to have is an odd number here and an odd power there. Sorry, a positive number here and an odd power there. Okay, and that's going to give us that low to high. So again, all this stuff doesn't matter. This is the key. Positive number here, odd number there. Okay, almost done. I know these notes are a lot of pages, but they go by pretty quick. Next, sketch a graph of a polynomial function with a negative leading coefficient and an odd degree. Okay, negative and odd. So think an odd degree, think like a line with a negative leading coefficient, which would be like a negative slope. That's going to be going downhill, right? So something like this. So that is high to low. Okay, and then this is really what we want, is just something that's high to low. Okay, so then it's got to start high, and then I don't care what it does in the middle. It can come up here, go back down, do another little dip. It could look something like that. We don't have to have all these fancy dips. I mean, it could literally just be a line. As long as it's high to low, then that's what we're looking for. If you have some little curves in between, that's perfectly fine too. Okay, and then this is not really applicable this year, but if you were to check someone, check the graph of someone sitting near you, what would you be looking for in order to tell if his or her graph matched the criteria set out in the instructions? Well, does it go from high to low? That's really what we'd be looking for. It just doesn't go from high to low. Any graph, as long as it goes from high to low, would work. And that's pretty short, but that is it. That's 3.1.